Hi, my name's Ed Burns. Before we begin, I'd like to tell you a little bit about myself. I have been working on Java-related technologies for a very long time, as you can see on the slide here, and I've had the pleasure of having a broad depth of experience from the client to the server and now into the cloud, dating back to my involvement with the early part of the web with NCS and Mosaic, moving into the server side with JCP and Java EE, which is a key aspect of our talk today, and now recently joining Microsoft to help promote these same technologies for use on Azure. Here's how I'd like to spend our time today. Let's talk about messaging. I'm going to put messaging in the context of the broader software development picture. Then we will talk about the various pathways to Azure Service Bus with Enterprise Java. We'll then do a JMS 2.0 deep dive, and this is where my experience with JCP will come into play. And finally, we'll have a conclusion and roadmap. Let's talk about messaging in context. I believe that messaging is absolutely essential to modernization efforts. It plays well and, in fact, is enabling for the Microsoft Azure WellArchitected framework, which I will talk about. And in the context of what we're doing here today, Azure Service Bus is an implementation of a Java messaging system, as well as many other kinds of messaging technologies. The first bit. You may have seen these blue boxes before. This is from the Reactive Manifesto. The Reactive Manifesto is probably about a decade old now, and when it came out, it was something of a revelation. But for those of us who've been doing distributed systems for a very long time, we recognize it as a nice way to represent the concerns that any distributed system that is going to work in the cloud needs to have. So it's important enough to have its own box. You know, there's only 6 boxes on here, and messaging is one of them. So it's important because it forces developers to embrace asynchrony. As the cloud was maturing, the need to have non-blocking I/O and operations that did not wait and allowed for maximum CPU density was increasingly important. So the ability to have an API that allowed you to write code such that you do a thing and then you separate the doing of the thing from the completion of the thing into 2 different points in time. This is a bit of a different way of programming, so having APIs that do this well and enable developers to understand how the messaging works in an asynchronous fashion and still continue to be able to reason about their code in a sensible way became more and more important. Another thing that messaging enables is loose coupling of services. Even in a so-called monolithic application where you have a large body of code with potentially very deep call stacks, you do have some decoupling of monoliths that can call each other using a messaging service. The message-driven aspect of the Reactive Manifesto also enables responsiveness, as you can see on the diagram here, and horizontal scalability. By that I mean you can throw more resources, compute resources, at the problem to enable a higher throughput of messages. If your problem is you're not able to process the messages fast enough, well, the messages are already on a queue, so you can simply add more consumers that will process those messages in parallel. That's one of the strategies that's enabled by using messaging in this way here. Let's talk next about the Azure WellArchitected framework. The architects at Azure have given a lot of thought to what it means to build a high-quality, resilient offer for the cloud, and you can read all about it and even take some Microsoft Learn training by following the URL you see on your screen right now. These are the pillars of the Azure WellArchitected framework. Reliability, meaning kind of resiliency. This is really another spin on the Reactive Manifesto. You could say that the Azure WellArchitected framework implements the tenets of the Reactive Manifesto, as well as having a lot more aspects to it. And that's not the subject of this talk, but I do recommend you take a look at this link and learn more about it. As it applies to messaging, the messaging deals with the reliability by having things separated with a message queue. If a node goes down, other nodes are up and they're able to process the messages, and you don't lose anything. There's a quality of the Azure Service Bus and other messaging frameworks that is called guaranteed delivery, and that enables reliability because things don't fall on the floor. The other one I'd like to call out is performance efficiency, the ability of a system to adapt to changes in load. And you know, if your queue is high performance enough, and we'll talk about the different pricing tiers of the Azure Service Bus, that will give you the ability to handle the load as it scales up and scales down. Now, messaging itself, it's so old that it even has an acronym that no one uses anymore. Message-Oriented Middleware, MOM. This was an acronym that I remember encountering in the early days of J2EE, probably in the early 2000s. But that term is not really used much anymore. In fact, middleware is not used that much anymore. But Java Messaging System is the standard Java API that was developed to address messaging on the Java platform. And JMS is kind of the lowest common denominator in Java for messaging. Now, lowest common denominator often means, okay, it doesn't have all the best stuff. It's pretty low bar. But it turns out that the JMS 2.0 spec itself is quite capable. There are other things you can do that are not in JMS, and Azure Service Bus has numerous features that go beyond that, but JMS is good enough for most cases, and that's why it's so widely implemented. These are just a few of the implementations of JMS out there. TIBCO EMS, WebSphere MQ, JBoss Apache Active MQ, and Azure Service Bus, as we'll see, and there are others as well. There's also a very mature release cadence you can see with JMS here, 1.0 being in 1998, 2.0 waiting a long time into 2013, and right now in development we have Jakarta Messaging, which is the latest name for JMS, that's in development now and should be out in sometime with Jakarta EE 10 in 2022. Let's talk about modernization now. There are inherent properties of messaging that enable non-disruptive modernization. You can, for example, have an existing on-premise stack that's using an off-the-shelf JMS provider, like TIBCO, for example, and you're using the JMS API and you're using producers and consumers, right? And you might want to then switch the destination queue over from TIBCO to Azure Service Bus, and all the rest of the parts of your system are still consuming the JMS API. It's just that the messages are going to be flowing through a different implementation. And the way you specify that in Java code is something we'll see in the demo, but it's a non-disruptive change in that it's only a configuration change. Another thing that enables modernization is ubiquity. We do find that JMS is ubiquitous in Java enterprises, and that is especially underscored by the fact that it's in both Spring and Java EE. So when you combine Spring with its over 60% market share and Java EE with its mostly remainder of that, you have all of enterprise Java covered. JMS is one of the big 8 Java EE APIs that are found in Spring applications. The others I've listed here in my subjective decreasing list of importance to app developers. Inject, because dependency injection is essential to Spring. Servlet, Bean Validation, JSP, going down the list in decreasing order of commonness in my experience in dealing with enterprise applications. This ubiquity also means that it's useful for interoperability. Now let's talk about Azure Service Bus messaging. It's a fully managed Azure cloud-based enterprise message broker. It is compliant with the WellArchitected framework, even though the WellArchitected framework sort of emerged as a way of thinking afterwards. It happens to implement all of those things. It has idiomatic language support in all of the popular languages today. .NET, Java. On the Java case, which is the focus of this talk, we are going to be covering JMS 1.0 and 2.0, but there's another way to access Azure Service Bus from Java that does expose the full breadth and depth of the functionality of the product itself, and that's via the Azure SDK. So that's a whole nother talk that we will have some resources on. Python, TypeScript, and Go also have APIs to access the Azure Service Bus messaging. There's so much more than just JMS that's involved in Azure Service Bus messaging. It does use the AMQP high-performance protocol for messaging. It does have very good, as you'd expect, first-class integration with other Azure services, event grids, logic apps, functions, Power Platform, Dynamics 365, and Stream Analytics. Let's talk about the concepts of Azure Service Bus messaging, which have a very decent overlap with the same concepts in JMS. The first concept is called the namespace. It's basically similar to a resource group in Azure, and it's really the container for all messaging components. It's almost like a billing and management construct because you can govern your things using Azure Governance, and that applies to all of the things that are inside of the Service Bus messaging namespace. So inside a namespace, you have any number of queues and topics. And the queues and topics are the two concepts that are most commonly used in JMS as well. So with a queue, you can think of it as just a producer-consumer. Those are the classes that are used in the JMS API. And topics are also supported using a similar thing. So it's the topic is a way to have multiple consumers with one producer, and it decouples the number of receivers in this diagram and consumers in the JMS speak from the sender. Let's talk about the Java pathways to Azure Service Bus. The message we've been telling and we're continuing to tell is that Azure gives you Java your way. And that's important because if we tried to give you Java our way, then it would look way different than what you're already doing. So in the cloud, we know and we recognize that we need to meet customers where they are, and that's especially important to modernization. Not only do we give you Java your way, but we give you messaging your way as well. Depending on how your needs are, we have different pricing tiers for that. There is an abundance of choice for Java on Azure, and that applies to messaging as well. This diagram shows that we have three main stacks, which mirrors what is being used in the industry. The first is the core Java SE stack. Microsoft has their own fork of the OpenJDK that's optimized for Azure and has a number of other great qualities that make it suitable for use in the cloud, such as full support. Jakarta EE is the current name and host of development for the JMS specification, as well as all the other specs that are a part of the Java EE umbrella, such as context and dependency injection, bean validation, EJB, and then we have the Spring ecosystem. The Spring ecosystem is very well supported on Azure with the Azure Spring Cloud Service, and also with Spring Cloud for Azure service integrations. So in that case, for Spring Cloud for Azure, you are able to bring your own Spring implementation and runtime and have idiomatic integrations to all of the Azure services. So we have a first-party service for you that makes it really easy to use, and then we also have the idiomatic integrations with Azure services. But that's not the topic of this talk, except to say that Spring has its own JMS support, and that is integrated as well, and we'll see that in the demo. Here are the pricing tiers for Azure Service Bus messaging. The one that I'll be talking about is the premium tier, and that's where you get the JMS 2.0 support. If you'd like to see more details about this, you can take a look at the link on the bottom of the slide. All right, let's dive now into JMS 2.0. First, we're going to take a look at this demo. Here are the resources after deploying the demo app. All of them are in my resource group. We have a backend app. This is the JBoss EAP app running on App Service. We have the front end app. This is the Spring Boot app, also running on App Service. And we have the App Service plan that contains both of them, and the Premium Tier S Service Bus implementation. Let's take a look at the Service Bus queue. We can see we have a lot of requests and messages going through the pipeline. Right now, all of them have been processed. We'll send a few through very shortly. I just wanted to show the front-end configuration in App Service to show the data out every time we click the post button. And on the back end, we can see the same thing when we are processing the data coming through. Now let's look at the tail of the application. You can see we have data coming through now. The employee payment system is processing payments. And if we go and look at the queue, you can see they're starting to show up right there. Now we're going to artificially pile up messages in the queue by temporarily removing the SAS key from the back end, which will cause the app to restart without an ability to connect to the queue and take the messages off the queue. We'll delete this, save the value, and this will cause the app service plan to restart the app service. All right, we can see that it was not able to connect to the queue because there's no key, so that's a helpful error message. We will go ahead and send some messages anyway from the payment application. Do a few of these. And now, if we look at the queue, we should see some messages start piling up. Okay, we have 6,000 messages so far. Now we have nearly 12,000 messages. Let's reset the key using the proper value. And you can see now we are processing the backlog of messages. Let's revisit the queue and see if they're starting to go down. Okay, we got up to 17,000 finally. Continuing to plow through the messages here. Now we're back down to 0. So our app has processed all of the messages successfully. All right, let's take a look at the code that was making this demo happen. The first part I want to show is the Java SE client. This is not using Java EE. It's not using any kind of injection or anything fancy. It's an imperative program with a main method that does all of the things. So because of that, you can see some of the extra complexity that Java EE takes care of for you. As I will tell you shortly, one of the major innovations in Java EE 7 was the ability to just @inject things, and you can @inject a JMS context. Here in Java SE, we don't have that benefit, so we have to look up the connector from the JNDI, and then we will call connection factory. So we're looking up the connection factory from the JNDI namespace on line 62, and then on line 73, we're using a Java SE 7 try with resources construct which is an important concept, and it's enabled because the JMS Context implements what is called auto-closable. So in the Java language, if you have a try with resources block, what you put inside the parentheses after the try is the set of resources that you will need to use in the enclosing block. And then when control exits from the block, the close method is automatically invoked. This is an important optimization that enables ease of use because you don't have to manually call close, but it also enables some JVM runtime optimizations because the compiler knows when things are going in and out of scope. So compilers love knowing that kind of thing because they can play lots of tricks to make performance better. So in this case, we are creating the JMS context. We're using the username and password syntax. That's not a best practice, but this is a demo. In general, you would prefer to use an access string. And in fact, for Azure Service Bus, the access string is what we're using under the covers anyway here, the connection string. So this simple demo, as I showed here, is doing sending 4 messages and then consuming 4 messages. You'll note that it's using receive body. This is a new method on the JMS 2.0 API that uses generics. So when you do receive body, you must pass the class, the Java class of the thing you're intending to receive. This will let you do type-safe programming. So if you are putting things out on the message queue that are not just plain old text, as long as they implement serializable, they'll be able to be serialized and deserialized across the message stream, which brings its own set of challenges, but that's another talk. In this case, we know that the messages are just text, so we can deal with them as text. Now let's take a look at the back end. The back end application, which was running on JBoss EAP and App Service, is a message-driven bean. So this is an example of the dependency injection that I talked about and the annotation-based way of working with your code. You are specifying the transaction management of type bean, and you're saying it's not needing to be transactional, but it is a message-driven bean. You have to give it a name, and we're specifying a number of configuration properties here. So here again are the types. The destination type we're sending to is a JMXQ. The acknowledge mode is auto acknowledge. All of those details are in the JMS API. And the destination string for the JNDI property that's in the JBoss config file that you can see in the demo, and also the connection factory that's used to create it. That is really all you need to do, and then the thing implements message listener. And message listener is the asynchronous message consuming mechanism, and it has an onMessage method that you implement, and you get past the message that you're dealing with. So this is an example of the asynchrony that I was talking about. Rather than, the one way that people often talk about it is don't call us, we'll call you. So here is an example of, we don't know when the thing's going to be called. We're going to get called whenever the message comes in, and it's going to, there's a new instance of it every time. So it's almost like a prefiguring of what we have with function-based programming. There's a little more boilerplate around it, but essentially the only thing that matters here is what's in the onMessage method. So we can see we are doing an instance of check, so that's a bit old school. We might be able to improve that without having to do instance of, because that's a dynamic operation that is not as, a bit good practice. It might be considered a bad practice, but this is a simple demo. That's the back end. Let's take a look at the front end, which is the Spring application. This is a Spring controller, and it has a method called send messages. And when I click the button on the UI, it was invoking this method. Same kind of thing as before with the connection string, username and password. We are getting the connection factory, and we're using the JMS Context with the try with resources syntax again. And here you can see that we're using the synchronous send. There is an asynchronous send as well that does not block, and I will cover that in the deep dive on the JMS API as well. If you want more details, I do encourage you to go and check out the code yourself, which is on the slides right here, the JBoss on App Service JMS. And that demo itself is based on a much more detailed, complete migration experience that my colleague Azure Service Bus was instrumental in developing. And that is this one, Migrate Java EE App to Azure Training. So I would recommend you start with the first one, and if you're still interested, you can take a look at the second one. Now let's take a look at some of the concepts that are enabled in this demo. The first thing I want to get across, people often say, oh, which is better, AMQP or JMS? They're different things. So here's a bit of UML review for you. The logo for Azure Service Messaging, Event Bus Service Messaging, is an implementation of JMS, and it uses AMQP underneath. So keep that in mind. Let's take a look at JMS 2.0. It's the most recent major revision of the Java Standard API for messaging. It is a part of Java EE 7, even though now we are working towards Jakarta EE 10. But 2.0 was the first major update since the industry adoption of some very important practices, using Java annotations in addition to XML config, using dependency injection as a way to wire up your business logic with the infrastructure in which it runs. Fluent programming. That is an API design style where you have long method chains, and I'll have an example of that in the following slides. Another thing that is all about very present in Java EE 7 is convention over configuration. This is, rather than forcing the user to tell you how things should be wired up, there are defaults. And this, many of these things you might notice kind of came from the first reaction of the Java EE world to the introduction of Spring. Quick history lesson here. When Spring first came out, it started life as the running example in Rod Johnson's book J2EE without EJB, and there were some legitimate criticisms that were leveled against EJB 1.0 that were fixed in Spring. But Java EE 6 and Java EE 7 and beyond have really addressed all of those problems, and so it's a good example of innovation happening elsewhere and being applied back to the platform. So, new features. The big one is just this new API here that was introduced in 2.0 with the JMS Context, JMS Producer, and JMS Consumer APIs. The first one I want to mention is the JMS Context. Here is an example of the try with resources and the auto-closable. You can see that there are a number of resources in the code block here, and we are able to use them inside of the application try block, and then they're automatically closed, as I mentioned during the demo. The next example is the injection. Now, I didn't show injection of JMS Context in the sample, but you can see it in the slides here. Let's take a moment to talk about scopes. In programming languages, you have different scopes, static variables that are read throughout the entire program. You have local variables that are only valid inside the inside the function or method, whatever thing you're executing. And then you even have inner variables like, say, a for loop, which has an I that is only valid during the scope of the loop that's executing. Well, the same concept is present in CDI, context and dependency injection, and these different objects live in a certain scope, which have a time dimension to them. So Application is something that exists the entire length of the JVM. Session is something that is generally like a user session or an HTTP session, for example. In web applications, the request scope is something that is while you're processing an individual request. Something that exists in request scope was deallocated and made available for garbage collection when the request ends. You can also have things in a none scope, which means they're not retained in any way. So they're, as long as you're referencing them in the local, most local possible scope, they are able to be accessed, but then when you're done, they automatically get garbage collected. So in JMS, the @injected JMS context objects have a scope that depends on how you're using it. If you're using it within a transaction, the scope is the transaction. And if you're using it within a web app, the scope is the request. Thing to note about JMS context, it is a single-threaded object. So if you would like to have multiple producers and consumers that are usable in different threads, you need to create a new context from the existing one that you have. So let's say you have a JMS context that you obtained using some way, either injecting it or creating it. If you want to have a separate thread that uses producers and consumers at the same time, you would need to call create context to get another one from that existing one. Here is the fluent programming method chaining thing I mentioned. So because these producers and consumers are lightweight objects, which I'll talk about next, that means you can just create them and throw them away. And each step in this method chain here returns a producer. So here we're saying create producer, set to delivery mode, priority, and time to live, and then finally send. And this is an example of the fluent programming style that I mentioned. On the producer side, that's the context. Next we have the JMS producer. Some of the new features are delayed delivery. You can specify, send a message, but it will only send it, at some delay from when you actually ask it to send. For example, at the end of the day, if you're doing batch processing or some kind of delayed process, it's a useful feature. This is also present in the Azure Service Bus messaging premium tier also as a separate thing, but we implement it for JMS 2.0 as well. For producer, you can have blocking and non-blocking send. The demo I gave you uses the blocking send. So when you call producer.send, it will wait until the message is placed, not till it's consumed, but just like, goes into the system so that we can do the guaranteed delivery promise before returning. Whereas with the non-blocking send, this second method will return right away and will then call the completion listener to give you the status of whether it worked or not. I mentioned JMS producer is an example of a lightweight object, so you can create it, use it on the fly, and throw it away. And that is, in part, the ability to do that is enabled by the JMS context being an auto-closable object. So one of the things you can do in this is set properties that apply to all messages that are sent by the producer. So here we're, for example, saying producer, create property, set foobar, and then every message that's sent on that producer will have those properties set so that when the message is received, those properties can be queried and something can be done with it. So the properties are a metadata information. So we distinguish between the metadata and the payload the payload is the actual message itself. Let's take a look at the consumer. It also has a blocking and non-blocking operation. There is a blocking receive method, and then there's the non-blocking approach where you can set message listener. And that is also implemented with the message-driven beans. Okay, so I've told you a lot about JMS. I've told you a lot about Azure Service Bus messaging. I'd like to conclude by giving some architecture thoughts here. Was about modernization, and there kind of is an inherent tension in modernization. when you modernize, you want to use best-of-breed technologies, but at the same time, you want to maintain a degree of protection from vendor lock-in. So many times, the newer technologies are the ones that are on the cutting edge, and they're being put forth by vendors, such as Microsoft, and they're very feature-rich. So you might want to take advantage of all of those features, but the minute you do, you are locked in a bit to that platform. So the tension comes from wanting to modernize but still maintain a degree of portability, and some of the aspects that I talked about here, where we're bringing Java messaging via Azure Event Hub service messaging, and the fact that you can run that with any of the way we do Java on Azure. So that's Kubernetes service, VMs, Azure App Service, Linux, Azure Functions even, and Azure Red Hat OpenShift. All of those have varying degrees of suitability for a multi-cloud solution. So by using standard APIs such as JMS and standard runtime environments such as Kubernetes or OpenShift, you're able to sort of get the best of both worlds there. So it's a great combination. The ubiquity of JMS combined with the power of Azure Service Bus is a really good combination. So the way forward, JMS is evolving under the Jakarta project. You can see in the notes that there are some interesting developments in spring, saying that they're going to be basing themselves on Jakarta EE9 and Wildfly, which is the open source upstream of JBoss EAP, which our demo used for Azure App Service Linux, has made plans to announce that they're going to support Jakarta EE going forward as well. They're a major supporter of that. And you can see in the links that we have if you want to get involved in the JMS project itself, you can follow those links there. So thank you very much for your attention, and I hope you enjoy the rest of your Ignite.